morning, ladies and gentlemen. I welcome you all here in this session at TNB Academy today. It's a great pleasure for me to introduce our eminent speaker, Mr. Sunil Kumar today, who is going to talk to us about Haccp plan. This is a topic in which we should all be deeply interested, as Haccp plan is the key impulsion for effective implementation of ISO 22000 standard in any organization. So it is very important to know how to create an Haccp plan in an organization according to ISO 22000-2018. In this webinar today, Mr. Sunil Kumar will discuss this topic in detail along with some real life examples he has experienced in the industry. Our distinguished speaker, Mr. Sunil Kumar, has done his post-graduation in microbiology from Himachal Pradesh University, India. He is also a lead auditor in ISO 22000 and FSSC 22000. He has an industrial experience of around 10 plus years in field of manufacturing, quality assurance, quality control, and food safety management system. He has been imparting training to a number of organizations, entrepreneurs, and executives on various topics related to ISO standards, food safety, and management systems, etc. It was just a brief introduction of our guest speaker today. And now, ladies and gentlemen, please join me in welcoming Mr. Sunil Kumar. I may request Mr. Sunil Kumar now to please start his session on Haccp plan in accordance with ISO 22000-2018.
Good afternoon to all of you. Thanks to Apoor for in the behalf of TNB Academic that the Learning Without the Limit is initiative, and thanks to the whole TNB team for the initiation of and conducting this seminar. So I am Sunil Kumar, as Apoor have already explained me about my industrial experience and my graduation and qualification and the professional experience in the different food industries on the behalf of the different standard like ISO 22000, FSSC 22000, PRC, and also the food safety standards regulation and requirement as per the FSSAI. So today we will discuss on the topic of the HACCP and how the industry HACCP and how it will be implemented in the food industry as per the ISO 22000 requirement and also as per the FSSC 22000 requirement. Later on we will discuss about the HACCP hazard, that is a hazard analysis critical control point. So today in this session we will cover the introduction and history about the HACCP, terminology used in the HACCP, now the principle of HACCP, also the application of HACCP principle, and as per the HACCP, the CCP has a because CCP are critical control point that organization of industry have to for the production of food safe for the consumption. Playing a key role in the through the hazard identification, their like PRP through the program, their operational program, and later on their CA identification. So has play out a major role in the food so that they can connect it to their hazard identify as a physical hazard, biological hazard, chemical hazard, and also next in forward like other industries and European industry conducting out the halogen hazard and alpha beta hazard also. So here we will start with the introduction of HACCP. HACCP is actually stand for the Hazard Analysis Critical Control Point. It's actually a systematic preventive approach for the hazard identification in food, and it's focused on the processing and manufacturing of food, and it's aimed to deliver the safe food for the consumer, because the food industry always rely on their food should be quality consistent and they should be safe for the human consumption. So HACCP help it out the organization to conduct out the hazard analysis, then they set up their CCPs, and so that they can reduce the hazard at their acceptable level, and that the production of the food that should be safe. So here we start about the history of HACCP. In 1960, HACCP actually Okay, so here we start with the introduction part. Hazard analysis critical control point. Then it's a systematically preventive approach for the hazard in force, and for it's a systematic approach throughout the process-based approach. The hazard can be identified in each step and each process so that can be safe food can produce for human consumption. And then it's focused on the focusing that processing and manufacturing of food, and it aims to deliver safe food for the consumer and the human consumption that should be fit for the human consumption. So here we start with the history of HACCP, how it started, how it's originated, and how it's later on what it identified in different countries and different legal units. So in 1916, then HACCP is originated by the NASA, that is Pillsbury Company, and the U.S. Army Laboratories. Agenda behind that was development of HACCP to provide the safe food for aeronauts in space. So their main agenda is was to the aeronauts who was in the space to they send the safe food for their consumption. So in 1960 they originated the HACCP, and the development the HACCP plan. Throughout they produce the safe food is free from the type of any like biological hazard, chemical hazard, and physical hazard, and other different level of hazards. So in later on 1916, after that 1970, the is adopted by the US FDA for food safety within the USA. So as it has in 1960 originated by NASA, then later on the other countries also initiated to development their has a plan into the country so that they can produce a safe food. And then 1980, the use of HACCP spread in the different countries like in USA, also in the European country. In 1990, then WHO adopted the HACCP and became the part of legal units. So as it started off in 1960 throughout the NASA, then later on in US FDA, then other countries, US and Europe, then 1990, then NASA became the part of that European units. And now in the right now in other sessions also the HACCP is adopted by the all the countries of like in Gulf country, Middle East, Southeast, European. So now the HACCP is an approach for all the food industries so that they can produce a safe food for the consumption. And it's now a part of the ISO 22000 and also a part of FSSC 22000 and the different food safety management systems. So that was a history of HACCP, how it's what originated and how it's further development into different countries. The terminology used as the HACCP in HACCP plan and HACCP identification. So first is the hazard analysis, the process of collecting and evaluating information on hazards and condition leading to their presence to decide which are significant for food safety, and they should be addressed in the HACCP plan. So in the HACCP plan, the different level of hazard are identified, which one are physical, biological, chemical, allergens. So all these type of hazard are identified through the HACCP plan. Throughout the risk analysis is done, and the type of hazard which are significant, which are non-significant are identified to the hazard analysis. Then after doing the hazard analysis, their identification of the critical control point. These are the control point or step at which the control can be applied and is essential to provide the safe food and to produce the safe food throughout the identification of different level of hazards and the critical limits and a measurable criteria which separate acceptability from unacceptability. So after the identification of CCP, their critical limit is identified, and their critical limit is like identified and monitored throughout the process steps, and the monitor the observation or measurement of control parameter to assess whether a CCP is under control. As we done the hazard analysis, then we done the CCPs, then we establish critical limit, then we have to monitor this the critical limit, the CCPs. So because we have to prove out that the process is under control or not. So these are the criteria for the terminology which are used in the HACCP plan. And the last is the corrective action. These are the action to eliminate the detected confirm non-conformity. So as the CCP identified, their critical limit identified, their monitoring procedure identified, and the corrective action are also identified, because throughout the any observation or any deviation is observed, so against this deviation, against this observation, a particular corrective action, a preventive action is taken, so that that deviation or non-conformity can overdue and that can be reduced at their acceptable level. So these are the terminology that are basic used in the Haccp plan. And here are the Haccp principles. Like Haccp is a stand for hazard analysis critical control point. So hazard, that is dangers to health. Analysis is the investigation of hazard that are maybe physical, biological, and chemical. Then they're critical, and critical as a critical limit, because that is a crucial for the contamination or any contaminant. That is a most, that is a medium level, that is a low level. So these are the type of the criticality of the hazard. Then is a control. Yeah, control is that how do you control, how you giving the control measure through this CCP. So this is the critical point. So control are that the handling of the condition. So last is the point, that position in the process. So which control you have identified, and the control at the points which are critical control point, which are control points. So these are the position in the process, whether in the part of raw material, whether in the part of process. So here the Haccp plan having the 12 steps. To including the 12 steps, there are 7 principles. So as we have learned, the most of the industry and most of the organization just learn the trainer part or doing the training this part on the 7 principle, because never knows about their 12 steps. They just only focus on that they Haccp having 7 principle. No, as of not having only the 7 principle, they having a 5 step also. So total they are 12 step. Out of 12, 7 are the principle. So here are the 12 step. The first step is assemble the HACCP team, then describe the product, then identify the intended use, then draw the flowchart diagram and verify the flowchart diagram. In a assemble a HACCP team. In this HACCP team, the different stakeholders, different interdepartment, that the like, members can join and make a HACCP team. For example, one person from the quality, one person from the production, one person from the purchase, one person from the CSL, one from the supply chain, and so different stakeholder that can come into and make a HACCP team. So after the assembling of HACCP, then second step is to describe the product. So you have to describe which product you are going to manufacture, which product is making at the site, which product is you are going to produce, and which you making the sales of that product. So that is the describe their products. And third is the identify the intended use. After you describe your product, you have to give the intended use. I mean that intended use, that product is for which intended use is going to be used for. Like for example, it is a mid base, or it is a intermediate use, is a finished good, or is a in process use. So that is the type of intended use, for which intended use should be going to use as a bulk, or as FG, or in process, or as a direct use or indirect use. So this is the identification of like intended use. Then draw the flowchart diagram. Then the fourth one is a flowchart diagram, that your process flowchart, how you receive the material, how you store the material, how you process the material, how you make the finished good, how you transport the finished good, and how you store the finished good. So this is a flowchart diagram. Then is a verification of flowchart diagram. Once you make your flowchart diagram, then you have to verify it, because as all the team member of the HACCP team member, they have to verify the flowchart diagram. As for example, one quality member is there, one production member is there, so they have to verify that this step is this step is later to this, and this is a whole flowchart diagram, and we have to sign out at the that flowchart diagram. So this is a verification of flowchart. So these are the first 5 steps of the HACCP plan. One is the sample HACCP team, then describe product, then intended use, then flowchart diagram, then fifth one is the verification of flowchart diagram. After the five step of Haccp, there are seven principles. Just I have already explained it out. The 12 step of Haccp. So out of 12, five are the steps and seven are the principles. So here is the fifth steps that I can say the five step we have taken into that, and the sixth step started with the Haccp principle. So 6 to 12 is over Haccp principle. So the first principle is to identify the hazard. The first principle state that identify the hazard. You have to identify the which type of hazard into this process, which or type of hazard into the raw material. For example, one is a product is carrying out, so they having a physical hazard, biological hazard, chemical hazard. So first step is to identify the assess or identify the potential hazard. And second one is establish critical control point. Once you identified your hazard, then you have to establish their critical control point. At which control point they can be critical, which point they can be major, which can be minor. So you have to establish a critical control point. Then the third one is establishing critical limits. So then you have to identify it, and then you have to establish the critical limits. That at which critical limit the hazard can be controlled and the hazard can be identified. So these are the common step of the identification of the critical control point and to establish their critical limits. Then the fourth one is to establish the monitoring procedure. The monitoring procedure is to explain it out. The first step of your hazard analysis, then a critical control point, then you establish the critical limits. Then these critical limit when they establish, then you have to monitor their the critical limits, that critical limit at their acceptable level or not. So you have to monitor as per the frequency, as per the defined procedure, or as per the risk assessment, because basis on the risk assessment that critical limit can be more hazardous or can be less hazardous. So you have to make the risk assessment according to that, and you have to do their monitoring procedure according to their risk parameters. And the fifth is establish that corrective action. Once you make a critical limit, then you establish a monitoring procedure. So there should be a failure of that, and there should be a non-failure. There should be a failure of, and there should be throughout the failure or deviation. There should be conformity. There should be non-conformity. So when any conformity is coming through the process, coming through the raw material, coming through the finished good, coming to the in process, so their action should be taken. So as for example, any deviation is coming from the process, for example, the heating was not okay or heating was not done at the steps. So you have to take the corrective action for that, because that step is giving a non-conformity. So for that non-conformity, you have to take the corrective action that should impart that should close the non-conformity. Then later on this verification procedure. Once you done your corrective action, then verification procedure should be there, because when you taken the corrective action, you taken the some action, according to that you have to verify that action also. So for this principle you establish the verification procedure. Then after the verification, once you verification done, their record keeping should be done, because all the steps are conducted and their record should be available at the site, at the protection, at the quality ends. So at which stakeholder these steps is including, or which area it is including, their record should be kept. For example, that failure was on the QA parameter, their record should be available. If that parameter is hindrance to the production, so their record should be available at the production. So the area which including that the corrective action and their verification procedures, so their record should be available at their respective stakeholders and their area owners. So here is the explain it out the seven principle. First we learn up the five steps: assemble the HACCP team, then describe product, then identify the intended use, then we draw the flowchart diagram, then we verify the flowchart diagram, then we learn about the second principle, that is identify the hazard and their assess hazard, then establish a critical control point, then we establish the critical limits, then establish a monitoring procedure, then establish the corrective action, then verification procedure, then last will run the record keeping. So the Haccp principle, as we learn the conduct the hazard analysis, the first principle is the hazard analysis. So hazard analysis can be conducted out the risk assessment. We will discuss later on about the risk assessment also. So here is a preliminary step for the conducting the hazard analysis as a risk assessment, then FMEA, that is failure mode examine analysis, then QC data review, then we have to determine and establish the CCP, which can be identified through the Haccp decision tree. So Haccp decision tree is a help us to identify that which one is CCP, which one is OPRP, which is one is PRP. So the Haccp tree help us to identify this type of CCPs and OPRPs. So after we establish the CCP, then we establish critical limit, which are like internal, external specification, which always meet compliance regulatory requirements. Then we establish monitoring procedure like assessment of the CCP on defined frequency. So as the monitoring procedure identified, so which one is deviation, which one is non-conformity, which is non-conformity, conformity. So their assessment is done on the CCP basis and their defined frequency. So monitor procedure, you can't monitor, like you can't monitor at every second, you can't monitor at every hours. So basis on the risk assessment, basic on the CCP assessment, we have to define their frequency according to our risk assessment. So then establish corrective action in cases on a failure in CCP or any non-conformity. A plan corrective action need to be taken in place. So next we have to establish verification procedure like for the quality control, like testing, like calibration and validation. And establish the record keeping and document procedure like record keeping for each activity of Haccp. As we learn, all the 7 steps are like the 12 step are included, 7 principle and 5 step are included. So their whole step by step record should be available out. So here's the application of Haccp principle, like 12 step we have learned about the Haccp plan as a sample Haccp team, then their product description, identify intended use, flowchart diagram, then verification of flowchart diagram, then identify the potential hazard, then identify the CCP, establish critical limit, then design the CCP monitoring, then corrective action, verification, and record keeping. So we have learned about the 12 steps, and these are how it can be explained it out ahead, can be draw, or how it can be process and new Haccp plan. So here's a Haccp tree throughout the our CCP can be identified. So in the Haccp tree, we just take a preliminary question for that, because each and every step you can't plan every step is CCP or every plan is OPRP. You have to conduct a questionnaire based history. So on the basis of all this question, you can identify which one is your CCP or which one is your not any, that is CCP. So the first step is that the first question into the HACCP tree: do preventive control measure exits? For example, if you have any existing or any preventive control measure existing for the process, if it no, then is this control at this step necessary for the safety? If it's no, then it's not be a CCP. Then you can stop it out and you can't declare it CCP. Or if there is a non-preventive control may exit, then is a control at this step necessary for safety? Then it yes. Then you can modify this step into the process of the product. So if the preventive control may exit, yes, then you can further go to the next question. Is the step that is specially designed to eliminate or reduce the likely occurrence of the hazard on a acceptable level? The first question raised that if you having the preventive control measure exit. If you says yes, we having the preventive control measure, yes, then you can further for the next question. Is the step that is eliminate or reduce the hazard at acceptable level? If you say yes, then is that CCP. Then if you say no, there is not any that is not especially designed to eliminate the hazard. Then you can go to the further question, question number 3. Contamination with the identified hazard occur in excess of acceptable level, or could these increase to an unacceptable level? So if yes, then you have to go to the next question. Will a subsequent step limited identified hazard or reduce the likely occurrence to the acceptable level? Then it's yes, then it's not a CCP, then you can stop into your process steps. If it said the last step is not controlling the eliminated the hazard, then you have to define it at a CCP. So on the basis of question, this basis of the cautionary preliminary, you can plan it out your which step is a CCP or which step is not an a CCP. So as we said, we can say that if you're having a control measure, you're having the most CCP having a last control measure. Because for example, you're having a process step of heating, your process step of heating of like 90-degree. So at 90-degree, you most of your microorganism can be killed. So your first step is like mixing, then is heating again, then third heating, then second heating. So if you're having a three or four type of heating in your process, but your last step is saying that your last maximum heating is 90-degree. At 90-degree, you accept your all the reduce of microorganisms. So that step could be called as a CCP, because basis on your like first question to having a preventive control, you said yes, we having the control measure. Then you said that this step is particularly designed to eliminate the reduce hazard. Then you said no, this is not accept last. This is not a step involved to eliminate the hazard. Then you ask that can this the step can eliminate or identify the hazard in excess of acceptable level. Then you said yes. Then further, this step is to identify hazard, likely hazard to acceptable level. If you said no, then you can define it as CCP, because it's the last step you will define your step as a CCP. Because at the last step, for example, I said the heating of 90-degree. For example, you're doing initially heating at 90-degree, then you're doing the heating at 70-degree, but your most of the organism or your acceptable limit is at 90-degree. Then last step of 90-degree should be declared as a CCP, because at that step your all of the organism microorganism can be killed. So for example, the second one is in case of physical hazard. If you're having a mixer or a mixing or a magnet type, that in first step you're also taking your magnet or your identification of your iron particle into your steps. Then later second step you also including that you are reducing the iron particle. So when there is a step which have step which can eliminate their occurrence of hazard to the acceptable level, so that step should be declared as a CCP. So how do we identify? We identify the CCP through the decision tree, like for the Haccp decision tree. Before that, we have to do the risk analysis and or hazard analysis of the particular steps. So risk analysis consists of three interrelated components like risk assessment, that is scientifically based process. Then the risk assessment, that is based on the select basis on the option, like which one is your process or which one is your other apart from the process or in process, like your raw material or any other packaging process. So that is the risk management, how you do the risk management according to your steps or according to your options. So third is the risk communication to involve the stakeholder, like which the process area stakeholders or area owner stakeholders. So different stakeholder that should be communicated to the risk assessment. The use of consistent terminology can be a critical use, because in impact on the system efficacy and efficiency. If all the hazard are mixed and undifferentiated, it will be possible to rank and reduce the control activities. So all the type of hazard that should be, because if your process or your FG process or your in process particular, that should be in a stepwise based, and that because there are all the hazard can't be mixed, because through the mixing of hazard you can't be identified your particular hazard that is should be at acceptable level or not. So you have to rank according to their steps. So according to the ISO 22018, the hazard analysis consists of following steps, like a hazard identification and determination of at their acceptable level, then hazard assessment, then selection and categorization of control measure, and validation of control measure, and combination of control measure, and a HACCP control plan. That is a HACCP plan. So the hazard identification and determination of acceptable level, that several input can be support the process of hazard identification. For example, known hazard from the past experience like external information including epidemiological and other historical data, then information of hazard in the food chain, and extra and the general hazard identification like as we already discussed about biological, chemical, and the physical hazard. And this can be done from the following five sources. For because that the hazard can be evolved from the different steps, like it should be from the equipment, it can be from the material, it can be from the improper processing, it can be from the environment, it can be from the human activity. If I talking about the equipment, that equipment through the hazard, there should can be like for example a nut bolt and a and a loose chain and a loose motor and a motor noise. So all these equipment part can be a type of hazard. For example, in a nut bolt is there should be a physical hazard. If there any type of growth and a type of material stick into that, that should be lead to a biological hazard. If any imposing of there any chemical on this machine or any equipment, that can be type of a chemical hazard. So these are the sources throughout the hazard can be there. For example, in equipment can be there, in material can be physical or biological, chemical there. In proper processing can lead to a type of any hazard. In environment, any type of a microorganism or microflora is there in environment, that can also lead to a hazard. That can be biological, chemical, physical, because in the environment if there is type of present of any dust, that dust can lead to physical hazard. In if any type of microorganism in environment, that can be a biological hazard. So these are the type of the through the sources which can be hazard can be identified. And hazard can be related to like chemical, the chemical like from the raw material, or like for when the cleaning of an equipment, then the chemical used, then any chemical residues at the equipment can be a risk of chemical hazard. And the material, like raw material you are using and machine installation, then technical devices, then technology and method, that can be hazard because through the technologies not major to identify the any type of hazard in a processing and a hazard. So there be a chances of imposing the type of hazard into the technology and method also. And in process like activity measuring point, operational condition like abnormal or abnormal, then pressure, time, temperature, humidity condition, etc. Then premises, their window, lightning. So in the environment like pressure, time, temperature, humidity condition can also lead to a type of hazard, because if a time or temperature reading, if any rise in a temperature in there, there should be a microbial hazard. Or any humidity is there, there should be a moisture level like chemical, physical, chemical parameters hazard there. So in the premises like window lighting, that also can lead to be hazard. So from some of the example of hazard which are identified as per the UF tells USFD also there. So classification for the risk as per FCDA like high life-threatening illness caused by the different type of microorganism like Clostridium botulinum, Salmonella typhi, Listeria monocytes, Listeria E. coli. That's the E. coli strain. That is a mutant strain of E. coli. Then Vibrio cholera, Vibrio have Paramelicus, Valneria fucus, then paralytic selfish poisoning, then evangelistic selfish poisoning, then also a moderate or illness that is caused by the brucella like campylobacter and salmonella, shigella, and streptococcus. So that are the type of biological hazard through that which microorganism can lead to biological hazard. Then there are the chemical hazard, for example, naturally occurring toxins, because using some of the raw material like agri-based product or agri-based raw material, they having a natural occurring toxin that originated from the that earth originated from the farm. So that are the naturally occurring toxins. And food additive in excess, is a type of food additive or color or the flavor that, which are used into the excess amount, that should be a chemical hazard. So pesticide residues and antibiotic residues, environmental contaminate, like chemical contaminate from packaging, and also allergen. So these are the type of chemical hazard which can be originated into the process, your raw material and your equipment and your method on. So these are the type of hazard of chemicals. Then physical that can be in a type of glass, like metals, machine, filling, paper, plastic, and any type of jewelry, dead insects. your like hair, your hair, and because these are coming to dead insects. So this is a type of physical hazard. So when you identify your risk assessment through your hazard, identify any type of physical or biological chemical, you have identified your risk assessment. So then you're having to a selection of control measure, because which control measure you had that can be controlled or identified. So more than one control measure is often required to control the defined food safety hazard, or more than the one food safety hazard can control by specific control measure, and it is advisable to select the appropriate combination of control measure. So at each and every step you need to you establish the control measure, but it's not possible to reduce the hazard at their acceptable level, because you have to identify a particular or an appropriate combination of control measure that can reduce your hazard. So mostly the effect will depend upon the rigidness in which the control measure are applied. For example, the effect of sanitization activity for a table will depend upon the number of time it has been applied, whether once or twice a day. It is expected that the control measure evaluated for implementation. So when your control measure is like applied or identified, it should be validated before their use. Because when you once you've done the validations, you can be take a surety that if it clean it within a 1 day, or clean it in a 2 hour, or clean within a 6 hour, that can reduce your hazard. So it can be done through the validation purpose only. So assessment and categorization of control measure, following are the parameters for the assessment and categorization of control measure. So as the likelihood of failure of functioning, the severity of the consequences in case of failure of its functioning, and the assessment that should go the effect of identify significant food safety hazard, and location in relation to the other control measure. So when you identified any hazard, when you do the risk assessment, you categorization the control measure basis on their risk assessment. So which one is critical, which one is major, and which one is minor. So these minor, major, critical you can identify it only when you having the likelihood of their occurrence and severity of the hazard. If their likelihood of occurrence is low, their severity of hazard is low, so you can't explain it out as CCPO. You can take it into a PRP steps. So selection of control is that more than one control measure is, as already defined, that should be required to control the defined food safety hazard. So so these are throughout you can identify your hazard, because that is more critical, that is minor or major. So depended upon their criticality and their categorization, you can identify which one is critical, minor, or major. So here is the risk matrix. Throughout, you can take the probability or your severity of hazard. As a severity of hazard, like is low, medium, or high, or is probability is low, medium, high. For example, a step which is having the low steps, like having a low ranking, that is low ranking mean that is non-significant, and their probability of occurrence is also a low, so that is not significant. For example, any step having a like high, that having a significant is low, no significant, their criticality or probability of that is high, so that should be a significant. So on the basis of their probability, their severity and probability, you can identify that which one is more significant or which one is non-significant. So this is the basis on their criticality, that how you identified it's a particular hazardous or non-hazardous your steps. So this is the basis on the steps you can conclude it out your which one is your that critical, minor, or major. So on the basis of risk matrix, it's not mean that you have to taking a ranking of low, medium, or high, or one, two, three. You can calculate on the basis on your experience or basis on your risk of your process. So you can give your own ranking also. For example, there is giving high, low, medium, high, probabilities low, medium, high. You can give the probabilities minor, major, critical also. So on the basis of your process and steps, you can taking the numbering and taking the risk matrix according to that. So here are the example of hazard identification. irrigation and CCP through the Haccp tree. So I just take an example of that. Through that, it should be less taking a memberships for the industry owners or industry people who are taking the HACCP certification or HACCP plan. While you're making the HACCP plan, there should be help into that, so that you can how you determine your CCP, how you taken the control measures. For example, I taken a product of XYZ name. So the step is like heating of syrup in the evaporators. So their step is heating of syrup. So which type of hazard can be there? If you are doing the heating, mean heating is that you are reducing the microflora or microorganism from the steps. So the type of hazard can be biological hazard. And what are the control measures? For example, the minimum temperature to attain the heat treatment. As for example, you are giving a heating of like 90 degree, 89, 85 degree. So minimum heating temperature to attain the heat treatment. Then you have identified that this step is your CCT, because this is the last step throughout you can reduce your the reduce hazard at acceptable level, because your hazard is biological, and a biological that hazard that should be clean it out, and that should be reduced at the acceptable level at a particular temperature. So you set your temperature at 89 degree for 10 minutes. So mean your CCP is 89 degree for 10 minutes. So you should have to attain this 89 degree temperature for 10 minutes. So their critical limit can be plus minus 3. So like for example, their 89 temperature is there, from 86 to 92 you can achieve the temperature. Your temperature can't be less than 86 and can't be more than 92. So this is the critical limit which are you have identified, which have you that imposing into the process, that can be 86 to 92 degree. You when you do the temperature of 86 to 92, your hazard can be stopped. Hazard can be reduced at the acceptable level. Then you have establishing monitoring procedure, because first step is to identify the hazard, which one is hazard. Then you do the control measure, then you also identify the critical control point, then you establish the critical limit, that is 89 to 92 degree. Then you establish monitoring procedure, because is the step by step of HACCP plan implementation also, and your assessment of your CCP through that the HACCP tree. So then you later on you started the monitoring procedure. So they online like temperature monitor through the engineering control. If you're having engineering control on that, you can track into your engineering control. Or you're having any manual stop, then you can read out the manual record book into that. Then you can enter the temperature into that, because it's the basis on the process and basic on the equipment the organization have. So throughout you can evaluate their steps, because you have to monitor that. For example, the temperature is you have to monitor 86 to 90 degree. Then their temperature logger or then an online temperature monitoring should be available. If that not available there, their sensor or the temperature sensor should be there. Through their temperature the temperature reading is capturing. So you have to write down that the temperature monitoring reading. So after you monitoring the temperature monitoring reading, you like online temperature monitoring through your engineering control or PLC, or because you have to show the minimum temperature, that is temperature of each batch or temperature of fourth batch. The frequency you have to define according to your risk and according to your process. So this is a monitoring procedure. Then you define the frequency. For example, you establish the frequency of each batch. Then you can track each batch or every six batch. It depend upon your process, that which having you the process having risk, high risk or low risk. If you're having a low risk, then you can amend your frequency to fifth batch to 10th batch. So if you're having a not any robust type process, you're having a less robust process, and you're having a less control of that, then you have to control the each batch of this process. If any type of deviation observed, like if the temperature was 86 to 92, if you achieve the temperature of 70 degree, maybe there is a deviation. So there is a failure of your process, you and your hazard can be controlled. Then you have taken a corrective action of that. If I said the temperature is achieved at a 70 degree, but you have to achieve 89. So this there is a non-conformity when you're not attaining the 89. Then you have to taken the corrective action. So what are the corrective action? Corrective action are you have to again heating the your process, your steps till attain the required temperature. As we have given the example of the 70 degree, you have done the heating at 70 degree, but you have to heat at 90 degree. So there is a deviation, non-conformity. To overcome this non-conformity, you have taken the corrective action. So corrective action, what you have taken, you again reheat that process at 89 degree. So what is the information capture record for minimum temperature of batch is recorded. So if the temperature is 70 degree Celsius, then you have to write down that this batch was recorded, this was attained at 70 degree, then you reheat the again and achieve at 89 degree. So what is the responsibility? Because for example, the responsibility of this production area. So production executive, process production officer will overcome the responsibility of these particular steps, and then later the record of monitoring, there should be a book, there should be a copy of record where temperature is capturing. So this is a follow the throughout the steps of the Haccp plan, how you identify the CCP and how you record that the CCP. So this was the type of biological hazard. In case of the physical hazard, for example, we have taken magnet at a mixer. So magnet as a mixer can be imposing a iron type of iron particle hazard. So this is a comes into physical hazard because this is the particle. Iron particle is a is a beautiful to the your person because it's a type of iron. It's a particle which are can be eaten or which can be taken when the consumer taken the food. So this is come into the physical hazard. So what are the control measures which control measure the checking of like iron particle in fish food? Then what are the CCPs? So CCP which are you have identified that iron particles which are that should be less than 1 mm into size, or that's depend upon your risk and which depend upon your product, that how much iron particle comes into your product. So I've just taken an example of that. For example, iron particle, you should have an iron particle less than 1 mm particle. So what are the critical limits? Mean that iron particle should not be more than three particles. For example, if when you're doing the process, you're having iron particle are 5 or 6, that means that critical limit imposing a deviation or imposing non-conformity. So what is the monitoring procedure? After each batch magnet gets set, each batch analyzed for iron particle measurement. So for example, as we given the magnet at a mixer, there is an iron particle. So how do you check? You taken the finished good sample in number of 1 kg, 2 kg, depend upon your frequency, depend upon your this. So you can take a sample about that. So you have to check the like batch magnet, how the magnet is clean, and which frequency basis is clean. So frequency, for example, it's each batch, and what you have to take in the corrective action. For example, any particle come into your product, then each batch should be rejected. You can't reprocess that batch because once it's the in the last step of CCP, the hazard has come. You can't do the like uses of that product because in case of heating, you can reheat again. But in case of iron particle come, you can't take any action for that. You can't save the iron particle. You have to receive that or you have to reject that batch. So information capture is called for iron content in page food. So who is the responsible like for quality person or quality officer or for a quality executive who check the finished food sample for the iron particle, then who is the responsibility of that person? So how it will be recorded? That recorded of each batch or each batch record should be available. So it depends upon the which type of record you taking, which type of the frequency or which type of hazard, which type of risk basis on your process or steps. So you can identify that. So this was the whole step to identified hazard and the particular hazard identification throughout the steps. Because in each of our 7 principle we have established the basis of principle, established the critical limit, then a control point, then monitoring procedure, then verification procedure, then record there. So these are the process based approach that how you take the action for the hazard identification throughout the process, has taken the action according to your process steps. So this is how you implement the hazard as a plan into your food industry, because every food industry having the type of elimination, and they should want to produce a safe food for the human consumption. And all these hazard which can be identified as a physical, biological, chemical, which are only identified through the HACCP plan, and it can be reduced to the accepted level, because every hazard or every that type of any non-conformity that should can be reduced at their acceptable level. It does not mean that the that
Akash, ask your question once again, please. So, on what factor does the frequency of monitoring will depend upon? Will it depend upon the type of product or the hazard phase or the, any other criteria?
Okay, it's depend upon it's depend upon your hazard, that how it affected comes. Because for example, if you have any product of any powder form, because in the powder form it can be type of, it's depend upon the hazard, because it's a agri based product, for example. Because the type of hazard, it can be physical, biological, chemical. For example, it's an agri based product, there should be a possibility of pesticide also, and there should be a possibility of your that the microorganism hazard, like biological hazard, and there should be alpha toxin hazard should be there. So it depend upon your humidity, depend upon your material. And you ask the frequency, that what factor does the frequency of nutrient depend. So frequencies depend at what times of your that your risk or the type of hazards comes. For example, you said that microorganism hazard is there, physical type of hazard is there. For physical hazard, it's come inside. If at a frequent level it comes, then you have to you increase your frequency.
Okay, thank you. I hope, Mr. Akash, you got the answer. If there are any more questions for the participants, you may ask. Anybody, any question? I think there are no questions left, so we can end the session here. Thank you so much, Mr. Sunil Kumar, for such an interesting session on industrial hazard analysis critical control point. The session was very wonderful, well structured, and was presented in a very beautiful manner. Your more than 10 years of experience, your depth of understanding of this subject, ISO industry, and your ability to present this subject along with the real life examples produced one of the best webinar. We are grateful for the time and effort you
Yes.
took to share your thoughts and experiences with the NV Academy today. We all agreed that your lecture was very informative and motivating. We believe that all participants can benefit immediately from the process and guidelines you have suggested for industrial HACCP. We look forward to our next webinar with you soon. Thank you so much, Mr. Sunil Kumar. Thank you so much. I may now request all the participants to please leave the meeting. The webinar is ended here. Thank you so much. Thank you for all the participants.